If you now understood how to solve a problem using mesh analysis. Normally, if a circuit contains only resistors and voltage sources, it is very easy to apply mesh analysis. Now, we will discuss a slightly different concept on mesh analysis called super mesh. Suppose if you have a circuit that contains voltage source, resistors, and along with that if there is a current source, and the current source should be between two meshes, then we can call it as a super mesh. So if the current source is present between two meshes, that can be considered as a super mesh, and we can solve the problem by using super mesh concept and the same mesh analysis way. The advantage here is the number of meshes will reduce for each current source present. So if there is a current source between the two meshes, the total number of meshes will be reduced by 1. So look at this problem. Here you have to use mesh analysis technique to evaluate the three mesh currents I1, I2, I3. So this is the question. And we can see that other than the voltage source and resistors, you have a current source between two meshes. It is common if I am marking this as a mesh 1, 2, 3. Between mesh 1 and 3 you have this current source. So I can call it as a super mesh. As I told before, if there is one current source, the total number of meshes will reduce by 1. See here 3 meshes are there. So this is a current source present between two mesh. I am taking it as a super mesh. So now I can take here, consider only two meshes, because see here this together mesh 1 and mesh 3 I have the current source. Common to mesh 1 and mesh 3 the current source is present. So this together I can consider as a single mesh. So now 3 meshes are reduced to 2 mesh because of the super mesh concept. But current will not change. 3 currents are here, I1, I2 and I3. So this part current 10 ohm, 1 ohm, 7 ohm, we can see I3 alone, I3 is flowing this. That will not be changing. Same I3 only can, even we are considering as a single mesh. This current I3, this loop's branches current will be I3 only. So coming to the problem, as our normal step, identify the number of meshes. We have identified the number of meshes as 3. There are 3 meshes are there. And second step, but this is a super mesh, that I will come to that point. Now just assign each branch what is the current. Already here assign, in the question itself the assign current direction in clockwise direction I1, I2, I3. See, always when you are getting a mesh analysis problem, even if the current direction is not provided, assign it as clockwise direction. Irrespective of voltage source, you can directly assign it as clockwise direction. If the actual direction is opposite, your current value will be in minus. In minus sign you will get. That's it. So make it as a practice of always assign the direction in clockwise direction. That means the direction our clock needle moves, clockwise direction. So now here I am going to assign the current. This is I1 is shown. So this branch, the current shown will be I1 of course. This branch also current will be I1. Now coming to this branch will be common to mesh 1 and mesh 2. If I am taking mesh 1 current I1 comes down, mesh 2 current I2 goes up. I am going to assign in downward direction here. So I can write it as I1 minus I2. Now see, this branch only one current, that is given as I2. This branch also I2. Now comes here, this branch will be common to this mesh 2 and mesh 3. So I will assign the current here. I am taking mesh I2 in this direction, I3 shown is in this direction. So I am going to assign in same I2 direction. So this is I2 minus I3. So that is fixed. Now for this one the current is I3. This one also current is I3. Now based on that I am going to assign the polarity for each resistor. This is plus, this is minus. This is plus, this is minus. This is plus, this is minus. Plus, minus. Plus, minus. So we, and this one more is here. This is plus, this is minus. Current entering will be positive, current leaving will be negative. And this is the current source present between the two meshes, so we can consider this as a super mesh. Not this current source, this together, this mesh and this meshes together we can consider it as a super mesh. So we can consider these two meshes together as a single mesh like this. But remember, the current we are assigning in these branches will not change. Now we can apply KVL for this mesh and this super mesh. So now this is the super mesh. This is the super mesh. So we can apply our equations normally. So now super mesh, and we have here the mesh 2. So this is considered to be the mesh 2 and this is considered to be the super mesh now. So apply KVL first on mesh 2. Apply KVL now. Our third step, apply KVL. So first apply KVL to mesh 2. So mesh 2, see here, plus 2 minus, I am assign direction is like this. So plus 2 minus, minus 5 I2, plus 2 minus, minus 9 I2, plus 2 minus, minus 10, the current is I2 minus I3, and minus 2 plus, it is plus 4 I1 minus I2. Should be equal to, as there is no voltage source here, should be equal to 0. So the readjusting this equation, we can get it, we are getting as 4 I1 minus 28 I2 plus 10 I3 is equal to 0. So now we have to apply KVL to super mesh. See here, the current direction is like this. So plus to minus, so it is minus, the resistance is 4, the corresponding current is I1 minus I2 in that branch. Coming here, I3 in this direction. So minus to plus, plus 10, that current is I2 minus I3. Coming here, plus to minus, minus 1 I3, this one plus 2 minus, minus 7 I3, coming up minus 2 plus, it is plus 10, should be equal to 0. Now we need to readjust the equation. So we are getting the equation finally as minus 4 I1 plus 14 I2 minus 18 I3 is equal to minus 10, equation number 2. So now we have only two meshes, two equations only we have, and but the how many unknowns are here? I1, I2 and I3, three unknowns are here. So if you want to solve this, then you should get one more equation. So from where we will get that one more equation? That one we will get from the current source present. Now I'll show how to write the third equation. See, this is our current source present between two meshes, and see, this current is flowing upward and this branch current shown as 3 ampere. So if I am drawing the arrow of this current, this is 3 ampere. Actually, what is that current? This is a branch common to two meshes. I1, mesh 1 I1 is coming down, mesh 3 I3 is going up, and I am showing the direction up. It is same as the direction of I3. So this current I can write as I3 minus I1. I3 minus I1. And what is the value? It's already given us 3 ampere. So from here I can write the third equation. That means I3 minus I1 should be equal to 3. Or I can write this as minus I1 plus I3 should be 3. This will be our equation number 3. Already we have equation 1 and equation 2. This is equation 1 and this is equation 2, and now we got the equation 3. Now we can solve this problem. So the 3 equations and 3 unknowns we can solve by using the matrix method. So the coefficient, all the 3 equations I have been rewritten here. 4 minus 28 and 10 are the coefficients of I1, I2 and I3 of equation number 1. 4 minus 28, 10. For equation number 2, the coefficients of I1, I2 and I3 are minus 4, 14 and minus 18. Equation 3 is I3 minus I1 is 3. So the coefficient of I1 is minus 1, I2 is 0 and I3 is 1. Now find the determinant. Determinant is of this. When you are doing your normal way, be getting it as minus 420. Now find delta 1, replacing the first column by this answer, then delta 2, replacing the second column by this answer, and delta 3, replacing the third column by this. And we'll find delta 1, delta 2 and delta 3 for getting I1, I2 and I3. So when we are solving, delta 1 will be getting it as 8112, delta 2 in solving getting as minus 44, delta 3 is minus 448. So from there, if I am calculating, I1 will be equal to delta 1 by delta, it is minus 1.93, I2 is 0.104 and I3 is 1.06. See, we can recheck with a super mesh current term because that current I3 minus I1 is given as 3 ampere. So this is I3 1.06 minus I1 minus of minus 1.93. We are getting the same answer as 3 ampere. So that's the way we are solving a problem using mesh analysis with super mesh concept.